sequence and series, geometric. So sometimes a geometric progression or a geometric sequence can be used for these sequences. So if, for example, we have 3, 12, 48, 192 and 768, what we will find is that unlike the linear, the quadratic and the cubic, there is no common first difference, no common second difference, no common third difference, not even a common fourth difference. Instead, what we're going to find is that each term is multiplied by a common ratio, and therefore that causes the sequence then to increase or decrease exponentially. And the reason it's called a common ratio is because what we're doing is we're multiplying each term by a fixed number. And that number could be 2 or it could be a half. It could be 3, it could be a third, it could be minus a fifth, it could be 7. So it can be a ratio. And it's the ratio between each of the consecutive terms. So in other words, if I was to write down my first term, same as a quadratic or a cubic or an arithmetic sequence, the first term is going to be given by A. And we're going to use the letter or for our common ratio. So therefore my first term would be written as A. And then to get to the next term, we would multiply that first term by my common ratio, or whatever or is. To get to the next term, I would multiply by or again. So A or by or would be or squared. Multiply by or again, well, A or squared by or is A or cubed, A or to the power of 4, and so on. Now, if we look at each of those terms, what you might notice is that the power of or is always 1 less than n. So therefore we would say the nth term is A or to the power of n minus 1. So our general term for a geometric sequence or a geometric progression is A times the common ratio to the power of n minus or. And we have to be careful, it is only ever or that is raised to that power. Now this can be found in our maths tables, page 22. And we have to be careful that we're using the geometric, not the arithmetic general term here. Okay, so if we look at type 1, we have the nth term, t of n, is equal to A times or to the power of n minus 1. So what we want to do here is find the geometric sequence for t of n. Find the general term for this geometric sequence and find t of 7. So if we write above each term, term 1, term 2 and term 3, then the first thing I can write down is A, my first term. And then to find or, well, to get from 5 to 10 and then from 10 to 20, I can clearly see that I'm doubling it. In other words, I'm multiplying 5 by 2, I'm multiplying 10 by 2. My fourth term then we would expect to be 40 and then 80 and so forth. So what we're doing is dividing any term by the previous term to get my common ratio. So therefore we would say or is 10 divided by 5, therefore or is 2. So now I can write down my general term for my geometric sequence is A, which is 5, times or to the power of n minus 1. So again, making sure we're only ever putting in 2 to the power of n minus 1. So the 5 is not multiplied, is not raised to the power of n minus 1. So therefore, if we want to find term 7, well, that means that n is going to equal 7. So that would be 5 times 2 to the power of 7 minus 1, which is 5 times 2 to the power of 6. And again, you can put that all into your calculator, but just be careful when putting 2 to the power of 6 into your calculator. So we have 2 to the power of 6 is 64. And then if we multiply that by 5, we get 320. So in other words, the 7th term is 320. So because they only asked for the 7th term, you could have, of course, just kept multiplying by 2 until you got to the 7th term. but type 2 is where we want to prove our sequence is geometric. So if we want to prove a sequence is geometric, then we have to show that there is a common ratio. In other words, that common ratio is constant. So in other words, I can take any term and divide by the previous term. So term 2 divided by term 1 in the previous example was 10 divided by 5 was 2. And if I took term 3, which was 20, and I divided it by term 2, I also get 2. If I was to go back to the very first example and I had 12 divided by 3, I would get 4. And if I have 48 divided by 12, I get 4. 592 divided by 48, I get 4. So in other words, any term divided by the previous term will always be constant, and it'll always be that common ratio. Now, if we're not given the sequence of numbers, instead we're given just the general term, like in this example here, t of n is equal to 2 times 3 to the power of n plus 1, then what we will do is we will work out the previous term, so t of n minus 1, and dividing we will show for any value of n, it will always be a constant. So in other words, to get t of n minus 1, wherever there is an n, I'm going to replace that with n minus 1. So in other words, this n is now n minus 1. So therefore that gives me 2 times 3 to the power of n minus 1 plus 1 is just n. And therefore if I take t of n and I divide it by t of n minus 1, I have 2 times 3 to the power of n plus 1 divided by 2 times 3 to the power of n. So 2 will divide into 2, and then what we have is 3 to the power of n plus 1 divided by 3 to the power of n. And if we look here on page 21 in our maths tables, we have, when we have a base number is the same and we're dividing, then we subtract the powers. So therefore that's going to become 3 to the power of n plus 1 minus n. So n plus 1 minus n means that t of n divided by t of n minus 1 is equal to 3. And therefore that is a constant, and hence the sequence is geometric. Okay, so in the second example, we could be asked to investigate if a sequence is geometric or not. And therefore investigate implies that it may or may not be geometric. So again, we start by getting t of n minus 1. So wherever there's an n, I'm replacing it with n minus 1. So n minus 1 squared is n squared minus 2n plus 1 minus 3. So that gives me n squared minus 2n minus 2. And therefore, if I have t of n divided by t of n minus 1, I end up with n squared minus 3 divided by n squared minus 2n minus 2. There is nothing common there with the top and the bottom, which means I'm always going to have an n in my answer. And therefore, it is not a constant, and therefore it is not geometric. So you're going to go to page 216, and some nice easy questions today. Question 1, part 3, part 5 and part 6. So you're given the list of numbers and you just want to write down a, or, and then the general term. Question 2, part 3 and part 4. You're given the general term and they just want you to write down the first 4 terms. So sub in for 1 for n, sub in for 2 for n, sub in for 3 for n, and 4 for n to get the first 4 terms. And then question 4, you're given some t of n, so you're given some general terms, and you're asked to investigate, are they geometric or not? And in which case, state the type of sequence it is. So you could write out the first couple of numbers to see, is there a common difference, first or second common difference, and therefore is it linear or quadratic if it is not geometric.